Let's take a look at table 310.15b16. Now remember, I'm using the 2011 edition of the National Electrical Code Book. To show you, I'm using the internet freenec.com, which is based on the 2008 edition of the National Electrical Code Book. In 2008, we had table 310.16, which is the allowable ampacities of insulated conductors rated 0 through 2000 volts, not more than 3 current carrying conductors in a raceway, cable, or earth directly buried, based on an ambient temperature of 86 degrees Fahrenheit. In the 2011 edition of the code book, I'm on page 70-154, and the table is now table 310.15b16, which they have in parentheses, formerly table 310.16. They're pretty much the same table, so what I'm showing you here with free NEC, you can apply to the current edition of the code book. Remember, ampacity is how much current a conductor can conduct or carry. So we use this table to determine the conductor's ampacity. In the first column here, you simply find the size of wire. Then we have to find the rating of the wire. For instance, if I'm using type TW, then that's going to be a 60 degrees Celsius or 140 degrees Fahrenheit rated wire. If I'm using an XHHW, then that's going to be a 90 degree rated wire. But all of these wires, all of these conductor ampacities is based on an ambient temperature of 86 degrees Fahrenheit. So just as an example, suppose we were looking for, we had a size 6 AWG copper conductor, and I was using type THHN wire, which is a 90 degrees Celsius rated wire, and I wanted to know the ampacity. Then I would use this column. I'd go to this row 6, and you see that the ampacity for number 6 THHN wire is 75 amps. So you simply find your wire size, decide whether we're using copper, aluminum, or copper clad aluminum, get your temperature rating here, and then you just go across and down to whatever your conductor ampacity is.